Hi friends, welcome back. Next lesson on the time speed distance chapter. And this lesson we are discussing another important concept in time speed distance, and that concept is the concept of relative speed. And you see a lot of questions based on relative speed in time speed distance problems. So essentially when you talk about relative speed, the basic construct is, if you remember in the first lesson in this chapter, I told you that if there's an observer sitting at a point or observing from a point and there's a car moving towards it, then the observer is stationary and the speed of the car, if the car is moving at 50 kilometers per hour, this picture shows the rate at which the car is approaching that observer, and this picture on the other side shows us the rate at which the car is going away from the observer. So you will see both these structures in the normal speed situation. But when you talk about relative speed, you start wondering, or you start building the mathematics around what happens if the observer also starts moving. So if I have an observer who is moving in this direction, and I have a car which is moving in this direction. If this car is moving at 50 kilometers per hour and this observer is moving at 30 kilometers per hour, let's say this is also in a second car at which he is moving towards him, then this scenario shows the rate at which C1 and C2 are approaching each other. This scenario shows the rate at which C1 and C2 are approaching each other, right? And because in this scenario the observer is also moving towards the car which is approaching him, his speed, the observer's speed, gets added to the speed of the car. So in this case, the rate at which the car C1 and C2 are approaching each other, or the speed of approach, can be described as the speed of the first car plus the speed of the second car. So in this scenario, the rate at which car 1 and car 2 are approaching each other with these given numbers, 50 and 30, would be 80 kilometers per hour. So in opposite direction, you have one picture like this, and this picture can then become a rate of movement away from each other. So if you see this scenario where car 1 is here and car 2 is here, in this scenario, again the relative speed is 80 kilometers per hour. And the rate of movement away, this 80 kilometers per hour is defining the rate at which the two cars are separating from each other or going apart from each other. Going apart or separating from each other. This in this case 80 would be that rate, and in this case 80 is the rate at which they are approaching. So a typical question on relative speed could be that let's say there are two cars moving towards each other at 50 kilometers per hour and 30 kilometers per hour, and the initial distance between them is 280 kilometers. So typical question, after how much time will they meet? After how much time would they meet? So in this scenario, the way you think about this is that because the rate of approach is 80 kilometers per hour, and the total approach to be done, this car will come all the way inside and this car will also go this way. So the total approach to be done in this case is the distance of the first car plus the distance done by the second car, which is 280 kilometers. Hence, applying the speed into time equals distance formula, you will get 80 speed into time, which is the required variable, is equal to distance. In this case, the distance is also the total distance or the relative distance between the two. And in such situations, when cars are moving or bodies are moving in the opposite direction, the relative distance is always taken as the sum of the distances travelled by the two bodies. So in this case, d will be taken as 280, and hence the value of t would be 280 by 80, which is 3.5 hours. Right? So now if I want to start modifying this question and I tell you that same scenario, moving at 30, moving at 50, distance between them 280 kilometers, and instead of asking when they meet, I ask you when will the distance between them next become 280 kilometers. When will the distance between them next become 280 kilometers? So for that you have to visualize that first they have to approach each other and reach the meeting point. So the approach required is 280, and then from the meeting point they again have to separate by 280. From the meeting point they have to separate again by 280 for this scenario to happen, that the distance between them again is 280 kilometers. Of course, in this scenario you are assuming that they will meet and continue in the directions in which they were originally traveling. So the approach is 280, the separation is also 280, so the net distance to be covered is 560. And again, the speed in opposite directions, when two bodies are moving in opposite directions, they are not connected to each other, the relative speed is always sum of the speeds. So speed in this case becomes relative speed, time becomes t, and distance becomes 560. So relative speed into time is equal to 560. So if you put relative speed as 80, 80 into time is equal to 560. So the time required for 280 to happen again is 7 hours. 560 by 80. And instead of 280, if I had asked you a different question, and I said that after some time, again same scenario, moving at 50, moving at 30, original distance between them is 280 kilometers, and they start at the same time, let's say they start at 1 p.m. and then I changed the question to saying that after some time it was found that the distance between them was 200 kilometers. Then what time could it be? What time could it be? So in this scenario, you can think of it this way, that if you were to take the distance between them, you want to find a point where the distance between the two people is 200 kilometers. So right now in this picture they are approaching each other, and as they keep approaching, as they keep getting closer to each other, 280 will become 279, will become 278, it will become 277, it will become 200 eventually, where you will get a picture like this, that the 50 guy has come in and the 30 guy has also come in, and now the distance between them is only 200. So if you want to find the time for this, you just have to see that initial distance is 280 and now the distance is 200. So the total approach they must have done to with respect to each other, the total approach would be 80, because you have come closer by 80 kilometers, and that is the distance to be taken if you are assuming relative speed here, relative speed being 80, time being t is equal to 80. So this picture where the distance is 200 kilometers will happen after 1 hour, because 80 by 80 is 1 hour, and hence this picture will happen at 2 p.m. But this question has a catch. In this question, I'm not saying that they have not met. So if the question had actually mentioned to you that after meeting they continue in their own directions, so there will be a 200 sometime later also. A distance of 200 between them will happen sometime later also, and that will be when they cross each other and then start creating a distance amongst themselves. So when they are crossing each other, distance is 0, and then they start creating distance amongst themselves. They start creating separation amongst themselves. That will go with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and keep going till 200. So there will be a 200 while separating also. This 200 we have seen here is the 200 while approaching. So there will be a 200 while separating, and for the 200 while separating, what you have to do, is essentially that first, originally the starting distance was 280. So you'll have to complete an approach distance of 280, and then a separation distance of 200. So in this scenario, the total distance that will have to be covered will be 480, and since the relative speed is 80, time is t, speed into time equals distance, you have to place 480 as the distance here, and hence the value of t becomes 6 hours. So if they started at this position at 1 p.m., this second position when their distance between them is 200 and they are moving in that direction and that direction, that means they have already met and moving apart, this will happen at 7 p.m. So if you go back to that question, you realize that since the question just said that after some time it was observed that the distance between them is 200 kilometers, you should be wondering at this point, is it the 2 p.m. point or the 7 p.m. point? Then the question will have to say something, otherwise the question will have two answers. Either an option will have both the answers, or if not, then the question can't be determined, because you don't know which meeting point or which 200 distance they are referring to, the first one or the second one, right? So this is the relative speed when people are moving in opposite directions, and the other relative speed is this one. If this car is moving at 50 kilometers per hour and this car is moving at 30 kilometers per hour, the rate of separation is 20 kilometers per hour. 50 minus 20, that's how fast this guy is going ahead of this guy. So the rate of separation in this case is 20 kilometers per hour, and in this case, if I call this car 1 and car 2 respectively, then speed 1 minus speed 2 becomes the relative speed into time equals the relative distance, which again can be thought of how much separation you have to create, or how much approach you have to create. There'll be an approach picture also here, we'll look at that. But suppose for this picture I asked you this question, that they both started at 2 p.m. After how many hours will C1 be 140 kilometers ahead of C2? After how many hours will C1 be 140 kilometers ahead of C2? And for that to happen, because the relative speed is 20, you have to understand that from this point the separation between them was 0. If you want C1 to be 140 kilometers ahead of C2, you have to create a separation of 140, and the rate of creation of separation is 20 kilometers per hour. So 20 into t should be 140, and that will give you t as 7 hours. So if this was the position at 2 p.m., then this condition, C1 ahead of C2 by 140 kilometers, will happen at 9 p.m. And the other picture in this case is the picture where you are approaching. So you can have a picture like this: C1 going at 30 or C2 going at 30, and C1 catching up at 50. So in this case again, S1 minus S2, which is 20 kilometers per hour, would be the rate of approach. That would be the rate of approach, and hence if you look at this scenario, you see that 20 kilometers per hour is the rate at which this car is approaching that car. So all those questions that I asked you last time could be asked here. Let's say the starting distance is 120 kilometers. In how many hours will C1 catch C2? The answer is 6 hours, because we'll have 20 into t equals 120. So t will come out to be 6 hours in this case. Or you can be asked, when will the next time you'll see 120 kilometer distance? So for that, approach has to be 120 and separation has to be 120. So because for the next time you'll see 120 kilometers between them, the C1 has to catch up C2 and then move on. So total distance traveled here will be 240. And S1 minus S2 is the relative speed. So whenever you're looking at using relative speed, you just have to understand what distance to use. So in the next lesson, I'll be talking about a couple of questions where I'll show you how this works. But I hope you understood this, and I want you to practice this a little bit on your own. Try to work out different scenarios. You can always create questions like this and solve it for yourself. And make sure that relative speed thinking is working perfectly, especially the identification of how much distance I have to put in the S into T equals D formula. So the formula remains same for relative speed. S into T equals D becomes relative speed into T equals the relative distance, which is what you have to perceive in these questions, and that's the crux of these questions. So back with you in the next lesson very soon with questions on this based on relative speed. Bye for now. Thank you so much.